In this segment, we're going to be talking about factoring, and we're going to start off with the common factoring. So what does the word factoring really mean? Well, there's a lot of different meanings to it, but one of the ways that I wanted to look at it, for this section especially, is that it's going to change a question that probably has adding and subtracting in it into a question that is a multiplication question. And the reason why we want to do that is so that later on, when we get into higher mathematics, we can have a question where we can find the properties of zero. So multiplying something by zero doesn't change anything, which is very useful for higher order graphing at the higher grades in algebra. So that's one of the reasons that we want to use factoring. Another one might be used, as we've talked about earlier, about canceling. If we can factor a question, we can then use it in its factored form to be able to do some canceling, because we can cancel things in a multiplication question, but it's a little bit more difficult to cancel them in an addition question. Remember that when we talk about factors, when we talked about multiplication, they are identical terms that can be repeatedly added. And if things are added, then that means multiplication. So factors are things that could be multiplied to reach the original constant or an original expression. So in this case here, I have 6 items, and I could arrange them in a couple of different ways. I could arrange them in one big long row of 6, and so therefore my factors would be 1 on this side and 6 up here on the top. So a 1 by 6 array could do it. So 1 and 6 would be factors. I could also change these and align them so that they look like this, in which case I still have my 6, which is my original number, but now I would have 2 here and 3 across here. So 2 and 3's could also be factors. I could also arrange them this way so that I could have 3 down this side and 2 across this way. So again, 2 and 3 or 3 and 2 are again factors. So we have this repeated addition piece. We're repeatedly adding 2 here and then another 2 here, and then we have another 2 down here. So that's repeated addition, or we've learned that that's multiplication. So factors are repeated addition of things that are identical, or multiplication of things that are identical. And the identical piece is important. If you recall, when we did our division in the last segment, we have a question like 3x plus 6 divided by 3. We were given a clue. This 3 down here gave us a clue, and it told us that we would need to start off with 3 on one side. So that allowed us to figure out that we needed to have 3 down here, which caused me to understand that, okay, that covers my x's, but these ones over here are going to have to be in this configuration. So when we had our divisor, we were given a clue. If I was to be asked just to factor the 3x plus 6 without having the divide by 3 piece, I'd have to figure out what needed to be on this side myself. So that makes it a little bit more of a challenge, but it's related to our division, so it's not that much different. Just a reminder before we move on to our first question that for our purposes, our models are only going to allow us to have items that are to the second exponent. Because we're using an area model, so a length times width, that only gives us an exponent of 2 as our maximum. But once we show how it works with single variables and double variables and variables up to the exponent of 2, hopefully our students will be able to see the pattern, and we can move on to something a little bit more abstract once they understand how it works concretely with the lower level ones. So in our first question, we have 6x plus 4, and it says the instruction might be factor. So how many different ways could we factor this? Well, these are our numbers, 6x plus 4, so here's my 6x's and my 4's. And to factor means I have to change it into a multiplication, so I'm looking for what has to be down the side and what has to be along the top to allow me to have a rectangle that is made up of 6 x's and a 4. Well, there's a couple of different configurations we could use. We could do something like this, in which case I would have a 1 across this side, and then across the top here I would just have all of this duplicated again, so I would have 6x plus 4. And mathematically it would look something like this. So I've got a factor of 1 and 6x plus 4. If I wanted to try to make it into 2 levels, we might have a bit of a problem. But then again, maybe not. So here's my 6x's and my 4, and I can certainly line them up into 2 rows. So what would be up here then? I'd have 1, 2, 3 x's and a 2. And I could write it like this. And so as you can see, this was an addition question, 6x plus 4. And now I've changed it into a multiplication. 2 times one bracket. Remember we said a bracket is like one entity. It's like a bottle or a can or a box. And so I've got 2 of these boxes. So now I've changed it into a multiplication. 2 sets of identical things, 3x's plus 2. Can I do it into groups of 3, I wonder? So I've divided it into 3 different sections. That works nicely for my 6x's. I get 2x. And down here I can divide that into groups of 3, but then I have this piece left over. So I could get 2x plus 1 and a third. If I take this one and cut it into 3 separate pieces, I can do it, but it's not going to give me whole numbers. And just like our divisibility rules, when we say a number is divisible by something, or if we say it's a factor of something, then that implies that there's no remainders. So dividing it by 3 wouldn't work. How about 4? Well, dividing it by 4 solves my ones problem. That works out nicely here, but it doesn't really work very well for my x piece. So I'm going to have 1, and then these pieces are going to have to cut in half. So 1.5 x's plus 1. But again, it's not leaving me with whole numbers, so we wouldn't say that it would factor. So in this question, 6x plus 4, we can make it a factor of 1, but that doesn't change anything, so that doesn't really help us at all. So when we talk about factoring, we want to see what is the largest number we can put down the side, or the largest shapes we can put down the side, and still allow us to have whole pictures, no cutting them up into thirds or halves or sixths or anything like that. So we want no remainders. So if I wanted to factor 6x plus 4, my answer would be 2 bracket 3x plus 2, or 2 sets of 3x plus 2's. Let's look at a more complicated question. So we have 3x squared plus 6xy's plus 3x's. So we have 3 different terms here that we have to look for. And I'm going to first of all just kind of put all the pieces out in the front, and then we'll see how we can rearrange them. So here are all my pieces. I've got 3x squareds. I've got 6xy's. Remember, xy's are x high and y long. And plus 3 x's. How could I possibly go about rearranging these? Well, I'm going to take my clue from the fact that I've got 3, 6, and 3. All of those seem to have as a common factor 1 that we talked about. Common factors of 1 don't change anything. They also are divisible by 3. So I think I could probably put 3 things down the left-hand side. But I'm not sure 3 what things. But I'll worry about what they are later. So let me see if I can just rearrange these into 3 rows somehow. So this is looking promising. I can arrange things into 3 rows, so I can put a 3 out here somehow, but I'm not sure 3 what's. And this doesn't look quite right either, because everything here is x high, x high. Oh, if I turn these sideways, that should work. So that looks promising now. So what do I have to have here? I've got my rectangle, I've got all my pieces. What do I have to have down the side to make this work? Well, to make an x squared, I have to have an x across the top, and I have to have an x along the side. But my x along the side has to be turned sideways, so that it's x by x. So if I've got one of those to make this x squared, I need to have 3 of these. So I'll just duplicate those. And that should take care of my x squared. So x times x gives me an x square, x times x gives me an x square, and x times x gives me an x square. Now does that work for these yellow ones? These are x high, so these are x high. How wide do they have to be? Well, they have to be y across, so I'll put y's here and here. And that takes care of my xy. It's x high, and it's y across. So there's my xy block, and I've got all my 6 covered here. Now to make this x over here, it's x high, but it has to be 1 across, so that'll be put that over there. So therefore my answer to this question, if I want to write it in its factored form, would be 3x's times x plus 2y's plus 1 should give me what I have here in the middle. So I'll write it out. So here I have shown that I've got 3 x's in common. So I've taken my 3 x's, put it out in front. I multiply that by x plus 2y's plus 1. When I multiply all those together, I'm going to again end up getting what I started with. And if we used our distributive property, 3x times x gives me my 3x squareds. My 3x plus my 2y gives me my 6xy's. And my 3 times my my 3x times my 1 gives me my 3x's. So there it is in its factored form, with the highest number that I can stick out in front and all the different pieces producing a rectangle. So here's our question, 2x minus 6xy. So I'm going to put all the pieces together and then we'll see how we can arrange them for them to work. So here are my pieces. I've got 2x's and I've got 6 negative xy's. Remember that these were positive xy's. All my red things were always negative xy's. So I've got 6 negative xy's. So how do I go about arranging this? Again, I look at my numbers here, and 2 and 6. The greatest common factor between 2 and 6 is probably going to be a 2. So I want to make it 2 somehow here. So I want to make it in rows of 2. So if I make it in rows of 2, I should be able to do this. And there's my 2 rows, but something's not right here. They got to be this high. Right now they're only 1 high. Oh, I can turn these around. And now that looks promising. I've got a nice rectangle with no pieces left over. I need to have 2 things here, and they have to be x's, but they have to be up in a vertical position. And that'll cover my x heights for my x's and also my x heights for these pieces. Now across the top, this one needs to be 1 across. So I'm going to put a 1 there. And these have to be, well, they're x high, so they have to be y across. But they can't be y across, because if they're a y across, they'd be positives. And these have to be negatives. So I have to have negative y's across the top. And that should work. So what is my answer going to be? Well, I'm going to have 2x here. So to put that out in front, here's my first multiplication. And across the top, here's what's going to be inside my bracket. And I've got a 1, and I've got 3 negative y's. So I could write it this way. I've got a 1 and plus 3 negative y's, or minus 3. Now, saying plus a negative is kind of redundant. I don't really need to have to say it that way, but I could write it that way. I could simplify it even more by writing it this way. And just say I have a 1 and I have negative 3y's. And I don't have to put that plus in there because that doesn't really tell me anything other than an and. 1 and 3 negative y's. So I could just write 1, 3 negative y's. So both of those are acceptable. And so I've factored this one into 2x minus 6xy into 2x times 1 minus 3y. Or I could write it negative 3y plus 1. In that configuration, I still have the same thing. I have a 1 and 3 negative y's. I have a positive 1 and 3 negative y's. And normally we write it in this direction because it says we go from variables from highest to lowest. Depending on how picky your teacher might be, all 3 of these are acceptable answers. All 3 are correct. They're just different versions of writing the same thing. So there it is, common factoring. We take our original expression, put it in the middle here, just like we did with our dividend. We have no clue as to which my divisors are going to be, so I have to figure out what's my factor, what's my numbers that are going to have to go on the side here. Again, we used our understanding of our greatest common factor to figure out which one it's going to be, because we're always looking for our highest one. When we used 1, it didn't really change anything, so that didn't really help us at all. So we're looking for our 2 or 3 or 4, whatever's the highest number that goes into both. We have to look at how we're going to configure it, which way we're going to turn the x's or the y's. We have to worry about our positive and negatives. And again, we just fit it in so that we make our rectangle. And our answer is a multiplication of this side times this side. 2x is the factor and negative 3y plus 1 is a factor. So common factoring. In the next segment, we're going to talk about factoring binomials.